Hey, what's going on, everyone? Today I'm going to show you how to install certificates into the Splunk web browser using both OpenSSL and Windows Server 2012. Okay, so here's my topology. I have my Windows Server 2012 box. I have the role of CA installed on this box that's going to be generating certificates out of certificate sign requests. I also have OpenSSL installed on this Linux box right here that's going to be doing a number of things such as creating private keys, generating certificate sign requests, and also modifying various file formats. And then also I have Splunk installed on this box as well. Okay. So to begin with, we can see that I already have Splunk. The web interface is open. There are no certificates installed on here. And the problem with that, of course, is that if I enter my username and password, okay, well, anybody that's doing any kind of reconnaissance on the network, and I'll just kind of filter that out to just include HTTP post traffic. I think that's that right there. But anybody that's doing any kind of reconnaissance on the network can see that the username and the password was sent over in clear text. Okay? Anybody that has this information can access the server and potentially do a lot of damage. So this is something that we're going to change. So to begin with, I'm going to create a couple of directories. Root a CA directory where I'll be working in. And in this directory, I'll also create some subdirectories, PEM for .pem extensions, DER, dir format, or dir encoding, certificate sign requests, and then also one for private keys. I also want to modify the OpenSSL configuration file, and I'm going to scroll all the way down to where it says this line right here, rec extensions, okay? Rec extensions v3 rec underscore rec. And I'm going to uncomment this. Okay. And the reason why I'm uncommenting this is because I actually want to include something in my certificate. And if you go all the way down to where it says v3 rec, under where it says key usage, non-repeat iteration, digital signatures, key encryption, going to add the following line, subject, alt, names, equals, at alt, underscore names. And the reason why I'm adding this is because I want all of my web browsers to be able to trust this certificate. And one of the things about Google Chrome is that it actually requires a subject alternative name within the certificate. If that's not included, then it will still say that the connection is not secure, even though it has been validated by your root CA server. Okay. Now you wouldn't have to put this in here if you're just using Internet Explorer or Firefox. This is just something that is very specific to Google Chrome. Okay. So I'm just kind of looking over that, and I think there's not supposed to be an S in there. Okay. Subject alt names and then alt names. Okay, that's good. Okay. So now I'm going to create a private key. To do that, I'm going to use the gen RSA tool. I'm going to specify the encryption, AES 256. Going to output that to a file called root CA. private, and I'll call this kaylee.private key.pem with a modulus of 2048 bits. Okay, so you have these three values right here. Encryption, output file name, and modulus. Okay, it's going to ask for password. And now I'm going to create this, I'm going to generate the certificate sign request using the rec tool. So open SSL, rec, new certificate, new, with the key that I just created, root CA, private, kaylee.private key, and I'm going to output that to a file called root CA, CA, certificate sign request, and kaylee.certificate sign request.pem. Okay, it's going to ask for the password that was that I used when creating the private key. And here you can just follow the on-screen prompts. It's going to ask you for information that you want included in your certificate. Okay, so for country, just put US, state of Providence, put Florida, location or city, you can put your city, PCB, organization, I'll just put X, Y, Z, organizational units, NE, and then put the fully qualified domain name, kaylee.section local, and email address, I'll put xyz at localmail.com. Okay, so that basically does it for the certificate sign request. One thing that I actually forgot to show you was the private key that was created in root CA private key, kaylee private key. Okay. So here's basically the private key that we had created before the certificate sign request. All right, there's the AES encryption, beginning of private key, and because this is in essentially the base64 format, or PEM has the PEM file extension, you're actually able to read some of the information that's in here. If this was binary format, we wouldn't be able to read anything in here. Okay. So now I'm going to take that certificate sign request, which is right here. I'm going to copy it. And I am going to open up IIS and drill down to where my search server is, right here. And I'll open that up. Okay, it's loading. All right, I'm going to click Request Certificate, Advanced Certificate, and paste that in there. And because this is a web server, the certificates template that we're going to select is web server. Click Submit. All right, things are running a bit slow today. I'm going to download in the DIR encoding. Okay. And then I also need to go back and I need to download the CA certificates as well. Okay. So both of these files have been downloaded, both the identity certificate and the root certificate. If I open that up, I can go to my downloads directory. There is the identity certificate, which includes all of the information that I included in the certificate sign request. And there is also the subject alternative name, which was done for me when I modified the OpenSSL configuration file. Here's the root CA. You can see that this is essentially a self-signed certificate. It was issued by my CA to my CA. And I'm just going to go ahead and rename these two files. Haley.cert.dir.formats. And rename that root.dr formats. Okay. Now, when we downloaded this certificate, and you could have downloaded it in either the in the base64 or the dir format, it really wouldn't matter. But basically, what it gives you is this certificate with this file extension of .cer. Okay. Which is essentially a security certificate. Well, this file extension is not going to work in Splunk, so we actually need to convert this file extension to a .pem extension. All right. So to do that, I need to transfer both of those certificates back over to my machine that has OpenSSL installed on it. Transfer that file, transfer the root into dir. And let me take a look at something real quick. Okay, cd.dir. All right, those are my two certificates. And I'm going to modify these two files so that they have the .pem extension rather than the .cer extension. So to do that, I need to use the x.509 tool. And then in the format, dir. And then the input file is going to be kaylee.dir.format.ser. And then I'll just output that to a directory, root ca, pem, and then kaylee.cert.pem. Okay. And I'm going to do the same thing essentially with the root certificate. All right. If I go back out one, ls.pem, I can see now both of those files. Okay, so there's my identity certificate and there is my root certificate. Okay, so let me actually look at that one more time. All right, so in order to install this into the web browser, we need to create a concatenated file that basically combines the identity certificate and the root certificate into a single file. So I'm going to use the cat command in order to do that. And let me just actually just go into that directory. It might make it easier. Okay, so I'm just going to say cat, and then Kaylee, and then root, and the order is important here. It goes identity certificate, then root certificate. And I'm going to concatenate that to a single file, and I'm just going to call this file, I'll call it Splunk cert.pem. Okay. All right, and if I look at the contents of that file, I can now see that basically there are two certificates in a single file. Okay, here's the beginning of the certificate, and here is the crap. Okay, hold on just a second here. Let me do this so you can see it a lot better. Okay. Oh, that's almost way too small. Okay. So cat and then Splunk.pen. Okay, so now you can see that a lot better. All right, so there's the identity certificate, and there's the root certificate in a single file. All right, change that back. Okay, so now, in order to get this to work, we actually need to create another file that Splunk will use when we start the server. And it's if we go into, let's see, cd root Splunk, and if I remember correctly, okay, yeah, okay, so here's the directory. And one of the files that we need to create in this directory is a file that will essentially load our certificates. Okay, so we're just going to say nano, create a file called nano, and we're going to call this file web.config. And what we need to do here is we need to create this section, settings, and these attribute value pairs. And the attribute value pair is going to be enable Splunk web SSL is equal to true. Okay. Now we need to specify the private key, and actually that's priv capital K-E-Y and then path, and that is in the root CA private directory, and then the file name is kaylee.privatekey.pem. All right. And then finally we need to specify that that concatenated file with both the identity certificate and then the root certificate as well. So root CA, and then what did I call that? I called it, oh, it's in the PEM directory, and it's called splunk.cert.pen. Okay. And I think that's actually pretty good. Now I'm going to actually restart Splunk because I want to show you something. What's going to happen if we try to start up Splunk without removing the password from the private key. Okay, so root Splunk bin Splunk and then restart. And this will actually just take a few seconds. It's not going to take a few minutes like this says. But we should get an error. And here's this error basically down here at the bottom. Cannot decrypt private key. All right. Without password. So we basically need to remove the password from the private key if this server is going to launch. Okay. So to do that, go back into where that that private key is located, and I suppose that we can really actually do this from any location. So open SSL, and then we're going to use this RSA tool that will strip the private key, or I'm sorry, we'll strip the password from the private key. Okay, so root CA private, and then Kaylee private key, and then just output that to the same location. Kaylee private key. And forgot to specify the in and the out values. Okay. So it's going to ask for the password to remove it. Okay. And now what we can do is we can restart Splunk again. And hopefully this time we don't get any kind of errors at all. And just wait a few more moments. Okay, it looks like everything started without any errors, and now the Splunk web interface is available on HTTPS. Okay, so if we navigate to HTTPS, haley.section.local, we can see that there is the key. The certificate is now on there. Has been signed by my root CA. There's the subject details that are included in the certificate sign request. And there's the subject alternative name. Okay. Want to make sure that all of our web browsers can hit this. So HTTPS, Kaylee.section. Spelled it wrong. Okay, got the green lock there. And verified by my CA. One more web browser to go. Kaylee.section.local. And there it is. Okay. So that's how you install certificates into the Splunk web browser. Hopefully this has been helpful. Have a good day.